Hello and welcome to the presentation for assignment 2 of COMP90024 Cluster and Cloud Computing by Team 9. So our members are Duoyi, Hongtao, Kuldeep, Naiyun, and Zexian. So first of all, I'll go over the basic system architecture. So our system consists of the CouchDB, which stores the Twitter and Instagram data. There is a Twitter Harvestor script, which gets the data from a Twitter database with Twitter API, and it saves the data in the CouchDB. It also does sentiment analysis to determine which tweets are useful and which are not. Then we have the application server. This handles the business logic. It also acts as a middleman. Basically, it gets the data from the database and saves it in the cache, so that whenever the web server requests any data, it just simply has to read the cache and doesn't have to go all the way to the database. This is much faster. And then it will read the cache when it gets a GET request, HTTP GET request, and it will return a HTML to the user. So that's the simple architecture. This is the more in-depth architecture. Basically, our servers, both web server and application server and CouchDB and the Harvestor, is built on top of the NeCTAR cloud, which we use as infrastructure as a service. So in our case, we have 4 nodes, so 4 instances, and the first layer is the web and application server. Both of these servers runs inside a Docker container. There's 4 Docker containers, and so the 4 nodes are inside a Docker swarm where there's 3 managers with 1 leader and a worker node. This just provides redundancy to our system. And then after that comes the CouchDB cluster. Again, this gives duplication, which provides redundancy, and so in case one node fails, another can just take over, and similar to the Docker swarm here. We make sure that the harvesters, they all get the data they get does not get duplicated, and that's the functionality of the CouchDB. It checks for duplication of data, and yeah, that's it.
For deploy the whole project, first we need to use Git to clone the whole repository from GitHub. The HTTPS link is shown on the screen, or we need just paste it and use git clone this, and it will clone the whole repository to your local laptop. You can see I have already done this part to save time. So after we do this, we will start with the Ansible part. First, we have created some Ansible script which will help us to first set up the instance, second, set up the environment in all instances, and lastly, set up the Docker swarm. So let's begin with setup instance. Just use sudo sh/run instance. So it will help me to create one instance on the NeCTAR dashboard. And it needs me to enter my NeCTAR password, so just paste it. And the root password, it will start to creating the instance on my NeCTAR.
And you can see there is one instance called instance1 is setting up in my dashboard. Yeah, it's done. So we want to create one more instance on our dashboard, so we will change the instance from 1 to 2 and run exactly the same script again. It's done. So we can see 2 instance has already been activated in our dashboard. So but we have already created 2 instances. So what we do now, we need to set up the environment for both of them. Before setting up environment, we need to copy the IP address of these 2 instances into our local host file. So just copy this one and place it here, and the same for the other one. Save it, and also for the configure cluster.sh, it will help us to set up our CouchDB cluster. So we will choose this one as our master node. Once we've done this, we will turn back to the working directory and just sudo sh:/in install test, and we need to enter our root password and also the password for the NeCTAR, and again the sudo password. It will help us to set up all the environments into instance. It shows an error because of the directory. We use this directory to test it on another laptop, so we need to update it here. So we just use pwd command to check the current directory, and we will copy this directory and back to the install file. Roles, set environment, task, make, and we can find it here. So we need to change the directory here. After that, we will run the code again. Just place the password again. Type in the sudo password. Now you can see there are green lines. That means the software has been stored properly, so nothing will be changed. For the red one, for the yellow one, that means it has changed. It do some change to the systems. Now you can see the cluster has been finished.
CouchDB cluster, we'll go to this link. Here we can see in the all nodes section, in the cluster nodes, we have both the IP addresses. So if we add one document in one instance, then it will automatically be replicated into the another instance. So now we start our harvester. So for starting the harvester, we'll just log in into our instance using the private key. Before starting the instance, before starting our harvester, we need to install the NLTK words which we are using in our harvester file. Now that we have downloaded the NLTK Word file, we'll straightly go towards the harvester, which we have cloned it from our Git. Now we'll start the harvester by typing this command. Run crawler will start our harvester, and we have to mention the the API, Twitter API name which we are going to use for this harvester. Suppose I'm going to use this name. Now it will start the harvester, and it will collect all the tweets from Melbourne City. Oops, I think we got an error. So first we need to create the database which we are going to use. Now that we have created a database, now this database will be replicated in the other instance also. Now we'll start the harvester again. Now you can see we are starting getting the tweets from Melbourne, and it's also stored in the database simultaneously. And this database is also replicated into the other instance.
This code will generate a Docker swarm automatically. There are 3 managers and a worker in the swarm. Initially, the leader of the manager will build an image locally and push it to the Docker hub. After that, it will create the swarm. Other nodes either work as a worker or manager will use the token to join the swarm. Finally, the leader will pull the image from Docker Hub and deploy the services for all the nodes in the swarm.
In this section of the video, I will briefly explain how we analyze the data we collected from social media compared with the data we collected from Orion. In the introduction section, we are showing a map which has all the positive Twitter across 30 different areas in Melbourne. And here's the negative Twitter. And here is the natural one. This chart demonstrates a linear correlation between the overweight Orion data and the gluttony tweets. Each point in this graph represents the ratio of values of Twitter counts percentage divided by the overweight percentage in this area. And clearly, the results show the linear correlation is not significant. One of the major reasons is that the amount of gluttony tweets that we collect is not sufficient enough to measure this kind of scenario. And here, we are trying to explore the relations of slot tweets on social media and people's actual overweight situation. Unlike the assumption, our results indicate a slight inverse ratio on these two parameters. Another intriguing interpretation of this graph is people living in areas like Melbourne CBD have the lowest overweight percentage among other areas. Our guess is citizens in central area have much more opportunity to access stream, local park and recreation center facility than people living in suburban areas. We further identify whether or not overweight people have the higher tendency of committing crimes. This picture exhibits the percentage of rat tweets only related to their location. As you can see, most of the tweets that have extreme content only occurred in Melbourne's CBD area, and such a result complies to the real-life situation. This was the brief analysis. Thanks for listening.